We'll now go into an informal discussion about algorithms. So remember, with computer science, it's all about solving problems. That's our end game, that's our goal. So how do we go about solving problems? Well, the main concept, the whole revolving idea with solving problems is that we create what are called algorithms. Okay, well, what the heck is an algorithm? Well, an algorithm is simply the list of steps for solving a problem. So if we're going to solve a problem, our task is that we need to design an algorithm, and then we need to develop that algorithm, turn it into a program, and use that to solve a whole variety of problems. So if we have a particular task, before we start writing a program, start hacking away at the keyboard to come up with a tool, we need to come up with a plan. So we need to know ahead of time, well, what is it going to take to actually solve this problem? So just to kind of give you an example, let's say you're building a house. I don't think the first step is to take a couple of 2x4s together, start nailing them, and add some glue and some more nails, and just start hammering away and hope you get a house built. I don't think you would go that approach. Usually you would start by a set of blueprints, a plan on how you're going to build this house. The same thing is true for writing a program. You don't just start hacking away with code. You come up with a plan, you come up with blueprints on how you're going to solve this problem. So that blueprint is our algorithm in this case. When designing algorithms, there are specific operations that are associated with the design process. So we want to go over what some of those operations are. So the first one is that we want to study the behavior of algorithms to determine if they're correct and they are efficient. So we're looking at the formal and mathematical properties of the algorithm. So we got to make sure that if we're going to design an algorithm, we got to make sure that it's, first of all, correct, because if we have an incorrect algorithm, that's not going to solve our problem. And we also want to make sure that the algorithm is efficient. If we write an algorithm that takes forever to run, then what's the point of having an algorithm if it's just really slow? So we use formal mathematical properties to show that the algorithm that we design is correct and that it's efficient. The next operation is designing and building computer systems that can execute these algorithms. So we're looking at hardware realizations. We're looking at making sure that we have the hardware that's capable of executing these algorithms so that way we can solve our problems. The next thing we're going to take a look at is the programming language. So we're going to design some type of programming language and then translate our algorithm into that language so that the hardware understands it. So this is the linguistic realization part of it. So once we know that an algorithm is correct and it's efficient and we have the hardware that's capable of executing our algorithm, we still need to turn that algorithm into a program. So we use what's called a programming language, and we'll get into that more details later on. But this is the language that our machine understands. So we take our algorithm, we write it in this programming language, and then the machine will understand it and execute the code to solve our problem. And then the last operation is identifying the important problems and designing correct and efficient software packages for solving these different problems. So this is where we actually create the applications themselves. So we write the programs, and then we make sure that the resulting program is working and it does in fact solve our problem. Informally, an algorithm is simply an ordered sequence of instructions, and these instructions are guaranteed to solve some specific problem. So let me just give you an example of the structure of an algorithm. This is not a specific algorithm, but it just kind of gives you an idea of what an algorithm would look like. So there's going to be some ordered steps. So we have here, for example, step 1 right here, and we're saying step 1, we do something. And then step 2, we're going to do something else. And we just keep repeating this until we have some steps here. We just say n, where n is some arbitrary number. So at step n, we just say we're done. So I mean, the whole point here is that we just simply follow this list of instructions in the order given. We don't just kind of just jump around wherever, but we just start at the very beginning. We just follow each instruction, each step one at a time. And then when we get to the end, our problem should be solved. That's the idea of an algorithm. Now, what about the operations themselves? These operations that are used for constructing algorithms? Well, these operations belong to one of three categories. So every type of operation that we include in an algorithm is part of one of three different categories. We have what are called sequential operations, we have conditional operations, and we have iterative operations. So we're going to take a look at all three of these in more detail. A sequential operation or a sequential instruction just simply carries out a single well-defined task. So when this task is done or when it's finished, the algorithm just simply moves on to the next operation. So we do one operation, and then when we're done, we'll just move on to the next. And then when we're done with that one, we'll move on to the next instruction. And we just keep going through and perform these different operations. So we just do one instruction at a time. Usually, these operations are expressed as just simple declarative statements. So just to kind of give you an example, we may say set the value of x to 1, where x is this variable, and we'll talk more details about it, but it stores some value. Maybe we say, well, we'll set the value of this variable to 1. We may say something like add a cup of butter to our mixture in a bowl if our algorithm is some type of recipe. Or maybe we have an algorithm that involves a checking account. So a sequential operation may be something like subtract the amount of the check from the current account balance. But the whole point here is that we just have this single task that performs some type of operation, and then we just move on to the next one. Conditional operations are the question asking instructions of our algorithm. So they simply ask a question, and then the next operation we do is based on the answer to that question. So we say if something happens, then we'll do this operation. Or if that does not happen, then we do something else. So to give you some examples, so if x is not equal to 0, then we'll set y to 1 over x. Otherwise, we will print a message. Or maybe if we're doing our cooking algorithm, if the mixture is too dry, then we'll add 1/2 cup of water to our bowl. Otherwise, we'll just move on to the next step. Or our checking example, if the amount of the check is less than or equal to the current account balance, then we'll cash that check. Otherwise, which means if it's greater than, that means you're trying to withdraw more than you have in your account. Otherwise, we can tell the person that there are insufficient funds. But the whole point here is that we're basically asking some type of question, and then the next operation depends on the answer to that question. Iterative operations are what we call the looping instructions. So instead of going on to the next instruction, they tell us to go back and we repeat the execution of some set of instructions. It may be a single instruction, it could be an entire block of instructions, but we repeat certain steps until some condition happens that tells us to get out of this set of repeating steps and move on to the next one. So to give you an example, maybe we'll say repeat steps 1, 2, and 3 until the value of y is equal to 1. Or we may say repeat the previous two operations until the mixture has thickened, where we check if something is dry and add more water. Or we may say while there's still more checks to be processed, we'll do the following 5 steps, whatever those steps are. But the whole point here is that we have a set of instructions that we keep repeating until something happens to say move on to the next actual instruction.